In this video, we continue our discussion about counting from when we looked at permutations, but this time we're going to look at something called combinations. And what are combinations, you may ask? Well, they're simply groups of things that we're trying to count. How many ways can I lump three things together? And there's a formula for this that's similar to the permutations one, but we have to divide by r factorial. So I want to know what's 5c3. Well, what that means, what this means right down here, 5c3, means we have 5 objects total, and I want to know how many groups of 3 I can create from those 5 items. Using our formula, we would have 5 factorial over 5 minus 3 factorial, which is 2 factorial, times 3 factorial. That's the r in this. 5 times 4 times 3 times 2 times 1 divided by 2 times 3 times 2 times 1. The 3 times 2 times 1 goes away. We're left with 20 over 2, better known as 10. And again, just like with permutations, this function is built into most calculators. You really need to find it in yours and understand how to use it. So we have 20 people reporting for jury duty. How many different 12-person juries are possible? So we have 20 people total. And I want to know how many just plain groups of 12 I can make. Because of the size of these numbers, I'm going to go to my calculator to do this. I'm going to type in 20C12. And I get 125,900. There are a lot of different groups I can make of 12 if I have 20 people to choose from. Now I'm going to go buy my wife flowers on the way home. There are 15 different types of flowers at this flower store. And I know that my wife always likes 3 types in the bouquet that I get for her. So how many different ways can I choose 3 types? Pause the video and try to do this calculation. So this is a combination because I want to put these flowers into a group. It doesn't matter what order the flowers are in that group. So I'm doing 15C3, and in our calculator that's 2,730. And lastly, how many seating arrangements are there for 6 students if there are 8 desks? Once again, pause the video and try to come up with the answer to this one. Now, this one, you've got to understand, this is not a combinations problem because I have 8 desks and it matters which desk I put what student in. If I put Billy into the first desk and Tommy into the second desk, if I switch them, that's now a different seating arrangement. This one, the order does matter. This is a permutation, and we have 8 things total to choose from, and we want to put 6 of them. We want to pick 6 specific desks, and it matters how I pick them in this problem. So here, using the calculator for this again, we get 20,160. And that's it. You really have to decide, does the order matter or does the order not matter?